you see, the difference between you and the person that has been on sites and has never been to a school is that sometimes they might understand the practice, but they will not understand the principle, which might make the disadvantage with that is that they will try to cut corners because they will ignore. Okay, let's say, for example, you understand because you have done materials, you've done mechanics and all these things. You understand that concrete is strong in compression, but it's weak in tension. You will not compromise on your reinforcement. But a person who doesn't know that will think, ah, okay, so I'll be teaching and sharing from a manual that I've been working on from last year. I think when we had the first discussion, I said that I wanted to talk construction technology in Africa. Now, before I start, I want to point out something that has become foundational every time. I think Engineer Chabala is here, a dear brother and a partner in business. I was with him in Lusaka at some point last week. We were sharing with agriculture engineers, and we shared on a concept called the T-shaped professional. The T-shaped professional. Are you able to see my screen?
Yeah,
Okay.
yeah, yes.
Okay. So the T-shaped professional is there are two types of professionals. There is what we call the I-shaped professional, and then there's a T-shaped professional. The I-shaped professional is a person that just knows one thing. I'll give it in the context because I know most of you are civil engineers. If you are a civil engineer and let's say you became an hydrologist or an hydrological engineer, I'm found with an hydrological engineer. So please, most of my examples that are outside construction will be with water, right? So you discover, right? You discover that you could be specialized in that. And it so happens that imagine at your church one day they are having a project and they say, oh no, we've got that engineer, she's a civil engineer. And then they're asking you about concrete mixing and you fail to answer. That's embarrassing, to say the least. So at least as an engineer, as a construction professional, as a person that is a practitioner in the infrastructure space, you must have a broad knowledge. So that's why we call it the T-shaped because um, it is broad. So it is broad. So it's like that. You know a lot of things. Of course, you're specialized in one thing. The I-shaped is just specialized in one thing. So I want you to have that understanding even as we start this discussion. The second point that I want to point out, another concept that I learned from my project management training, it's a martial arts. It's interesting when you're learning certain components of project management, we get to learn some Japanese terminologies that are used in martial arts. I did martial arts when I was very young. So there's a concept that they call shu hari. I hope I'm saying it correctly. So this concept basically deals with the stages of learning, how you develop skills. The show is the foundational stage where you learn the basic principles. Then the ha is the part where you now practice those. So you've learned them, you are now practicing them. And then the third, which is the re, is the part where you become so good you can teach. All right. My interest to teach this evening is coming from two places. First, I believe that as my own business grows, it's a bit selfish. I need to find people who we can work with. At some point last year, we had a situation where we got a lot of inquiries. All right, a lot of people got interested in our services. But because I didn't have a sufficient big enough team, I didn't have, and I've tried before subcontracting other people who end up messing up. So when they mess up, the cost of poor quality is that you have to redo the work or you lose your business partner or you lose your business opportunity. Sorry. So I would like to share some knowledge that I think can make more people become the right professionals. so that even if tomorrow I have a PJ somewhere I can't do it, I throw it to Engineer Ngulube. I should be confident that he's doing it in the name of Sky Pillars. It should be able to go. And I'm not joking about that. I quantified the business opportunities we lost last year because we didn't have the right team around us. Were actually in the range of about 20 million kwacha. So that's something. That's really something. So then the second thing is having interacted a lot with students and interviewing people for roles, I also saw the gap that Engineer Ngulube talked about. A lot of what is being learned in the classroom is failing to be translated into real life experience. Now, the problem is
Exactly.
not that, are you following me? All right. So the problem we are having is that there's a lack of practical aspect. Now, the problem is not the theory you're learning. The problem is that you've not been showed how to apply it. And one of the things that I'll try to do on this platform is to do that. Now, let's quickly start and go. Um, so Africa, because we're talking about Africa, I want you to understand that you've been excellent in your engineering, in your construction management, in your architecture, or whatever you're doing in the infrastructure space. It is very important not only for your career or for how much money you can make. I want you to understand that your projects will affect whether people get clean water. Your project will determine whether children have got a classroom to sit on, to sit in and learn. Your projects will determine how people are treated in hospitals and things like that. So infrastructure is not something, even agriculture. I mean, we're talking to agriculture engineers. There is a lot of infrastructure that goes into that sector as well. All right. Now, let me try and be very fast and just move and begin the introductory. What is construction technology? Construction technology is basically the systematic application of tools, materials, equipment, methods, and processes to plan, design, build safe, functional spaces. So I hope you're taking notes. Construction technology is the systematic application of tools, materials, equipment, methods, and processes to plan, design, and build functional, durable spaces. It sits It's at the intersection of civil engineering, architecture, material science, project management. We can even put quantity surveying there. We can put all the other fields, hydraulic. So in construction technology, you have to know a broad number of things that you have to understand. And the problem is, like I said, our continent needs this technology. Now, these three pillars of construction technology, this is from my own understanding. I came up with what I call the three pillars of construction technology. And by me just dealing with this, a lot of you understand why you're struggling on construction sites. The common misconception amongst students entering the construction field is that competence comes from a single source. So most of us we think that because, oh no, I've got a degree in civil engineering and environmental engineering, or I've got a degree in construction management, or I've got a degree in quantity surveying, I'm ready. No, that's one source. All right. So people think that there's a difference between the classroom, the site, or the toolbox. In practice, you have to understand that these three things work together: the classroom, the site, and the toolbox. Let me explain. So the first pillar is, I call it the engineering principles pillar. This is the science and structure. So, and a lot of you who did, especially those who did civil engineering, this have been learning the engineering principles. So you understand that under engineering principles, you learn things like structural mechanics, you learn things like soil mechanics. Sometimes this don't make sense, but they'll make sense as I go on explaining. You learn things like material science, you read hydrology and nature, right? One of our interns, I don't know if the people is here, I had to take her to a site which was very waterlogged. and I was showing her because she told me to specialize in hydrology site, which was actually very waterlogged. There's a site that we were helping them with project management, and it was very waterlogged site. So you need to know how to deal with water. So but there's a science. That's science. These things are foundational. They are not bad. They are not wrong. Don't think that they're wasting your time when they were teaching you structural mechanics. We now need to get these. So you see, the difference between you and the person that has been on sites and has never been to a school is that sometimes they might understand the practice, but they will not understand the principle, which might make the disadvantage with that is that they will try to cut corners because they will ignore. Okay, let's say, for example, you understand because you have done materials, you've done mechanics and all these things, you understand that concrete is strong in compression, but it's weak in tension. You will not compromise on your reinforcement. But a person who doesn't know that will think, since we don't have, there's a place where we were again. I think Chip again can bear witness. There's a site where we went to, where a bricklayer was building without putting brick force. Now, if I asked you, some of you people here, and I've been asking some of people because we've been trying to recruit for our team, you ask an engineer what is brick force, they don't know. But in theory, they know concrete requires reinforcement, right? So this is part of the problem that we are seeing. The first pillar is the engineering principle. The second pillar, I'm trying to, I'm just trying to move very fast. So bear with me because I might have to cover a lot of ground. The second pillar is what we call construction technology itself. That is the materials, practices, and the knowledge found on sites. So first you have to understand the engineering principles, the science behind our construction. Then you have to understand construction technology. This construction technology found on site, it's got its own language. It's got its own language. Now, what do I mean? You go on a site and you hear people talking about batching. You don't know. If I ask you, you're fresh from university, I ask you, today we need to do batching. Please write a works methodology for us to do batching. Some of you will be confused. In interviewing people, you tell people, I want you to do a 1 to 2 to 3. A person who's been in industry will know to say 1 to 2 to 3 is a mixture of concrete. That being measured by volume. So 1 volume of cement, 2 volume of fine aggregate, 3. You understand what I'm saying? Now, what happens sometimes is you have come, you're so pumped as this big engineer, you've got concrete technology in your mind, but you've never seen concrete being cast before. All right. So the second pillar is what we call the lived practical knowledge of construction. How materials actually behave, how traditional methods and modern methods are applied, what experienced practitioners have learned through years of building. I'll tell you, the first house I ever built, I built the first house. It's still standing, by the way. There's a house we built in Chalala as my first project when I started doing business. I was very young in industry, and even people take risks. Because I look back and ask myself to say somebody trusted me to build their house with how little I knew at the time. But being an entrepreneur, I pushed myself and I got this contract. We start building. And I had the privilege of working with two very experienced bricklayers who came from a Chinese site. And they had been exposed to the industry from the Chinese to the South Africans to these are the guys who even showed me what a water level is. I know you don't learn about water levels when you're doing your surveying, but there's a tool that we use, and I think in the notes I will share a little bit about it called the water level. Very simple, basic tool. You can buy it for 300 kwacha. If you go to Mickman tomorrow, ask for a water level, please buy it if you can. So these guys, they were doing levels with the water level. So I'm looking at them, I'm learning something. Now, the place where we were working, it's not a dolomite rock, it had a granite-like rock. Now, from my understanding from university, when you find a rock, we learned that you have to blast it out. which is extra cost for the clients and things like that and things like that. These guys came to me and said, boss, I was very small, and I even wonder why they were calling me boss. I said, boss, this rock, I don't think we need to take it out. I said, what do you mean? As they explained, so no, the type of rock is very stable. It's over a very big area. It doesn't look like it moves and whatnot and whatnot. So why don't we just chisel it, and instead of the concrete going into the ground here on this particular corner, we will do like a step. So I thought through what they said. And we did the step. But before we did the step, I went back to my books. There was a particular book I had which was explaining concrete. And this book explained concrete, defined concrete as a temporary rock we make because they were explaining how that at first they used to use actual rocks to construct. But then when technology advanced, we started now making our own rock, our own concrete, our own rock, rather using the aggregates and the cement and everything. So it clicked to say, okay, what these guys are saying is true then. If this rock is strong enough and it's able to bear this load and whatnot and what, I did my calculation and it made sense. I was able to save the client a lot of money. I was able to protect the environment from any explosive noise, pollution, and all these things and things like that. So when it comes to construction technology as a pillar of knowing construction, you need to know materials. You need to know materials, construction sequencing. Okay, so before you set out on a site, what do you do first? Before you excavate your trenches, what do you do? All right. So you have to know materials, you have to know construction sequencing. Like, and please, I hope that you are an engineer who is able to read and understand the BOQ. Because if you look at the standard BOQ, whether it's done in Zambia, it's done in South Africa, it follows the construction sequence. So, to say first we do site clearance. After site clearance, okay, we set out the building. When we've set out the building, we check the bottoms. Do we need to stabilize based on what we found? Remember your soil mechanics. If the soil is not good enough, we I mean, we stabilize. If we don't need to stabilize it, we can just do blinding. If we don't need to do blinding, there are different things that are needed. So your construction sequencing, what comes after what? Like I was given an example of brick force. Um, every 3 courses, for example, you are supposed to put what is called brick force wire. Sometimes go to these hardware stores. Go and look at some of these materials. There was a person who interviewed for a job the other week. And again, your generation is very interesting because the first question they were asking me was how much we were going to pay them and things like that and things like that. Of which, to be honest, because our revenues and as a business we are growing, we are actually very willing to begin to offer more competitive packages. But we're not going to pay you when you don't know anything. I think there are bigger companies that can not pay there. So I asked the person to say, what is the difference between DPC and DPM? And the person was blank. So I'm asking myself to say, but how are you demanding for a lot of money when you don't know the simple basic things that what is supposed to come at which point? Right? So if I ask
Yeah.
question on this platform without you cheating, because if you're cheating, you're just deceiving yourself. I'm not sure, I'm not giving you any grades. I want you to write in the comment. I want to see the comment at the end. What is the difference between DPM and DPC? Please write that down very quickly. I also want somebody else to tell me the sizes, the common sizes of brick for wire. I'm assuming people know what brick for wire is, but of course, I'll be able to talk a little bit about it as we go. Now, if you've seen, these are the basics. These are the first principles of construction. We can begin to talk about AI and BIM and things like that. And my manual actually that I'm working on, I was telling one engineer who's doing a research on BIM that I want him to write a chapter in my manual on BIM, which is building information modeling. You are not going to know how to give, even if today they invented robots that were able to build all these buildings. What prompts are you going to give these robots if you don't understand basic sequencing? If you don't understand basic workmanship standards? So we can start talking about, the fancy, like, of course, we're going to have a time to talk about it. We can talk about the what do you call this? We can talk about the digital twins and drone technology and all these things. But please, all those things are fancy things before we have understood the foundation. The foundation is you need to know the workmanship standards. What is the gauge of when they're doing block work? Do you know that there are certain gauges that you follow when you're doing block work? You must be able to walk into a room and say, no, this room has not been built correctly. These are the foundations. Pillar, the third pillar, and please, I want to read this statement. It says the construction practitioner who combines pillar one, which is scientific understanding, with pillar number two, site knowledge, is equipped to do more than follow instructions. So sometimes we go to a site. The architect who designed had never been on a site, but you understand construction. You understand the principle. You have this guy has put that we need to put a strip foundation. But when you excavate, you see the soil. You know to say a strip foundation cannot work here because of the nature of the soil. This is clay soil, or even if it's a strip foundation, maybe we need to do reinforcement. I told you about that waterlogged site. I had to insist to the client that we reinforce the entire footing. Why? Because I knew the behavior of the soil. So if you want to be more than a person that follows the robot, you can't be a robot. You've spent 5 years learning this engineering knowledge. We send you to a site and you're acting like a robot, then there's something. You must be able to adapt. You must be able to change things. All right? I'm building a house. I've built a house before on a hill. Now, the basic solution to building on a hill is people will tell you you need to cut and fill, or you need to cut, make it level, and that's when you build. But that's very expensive. What do? You can do a thing called the step foundation. Do you know? I actually shown this answer or this thing on the step foundation made me a celebrity in my class back in first year because our lecturer was asking about how do you save costs when you're trying to build and you're trying to do this, and no one knew the answer. And I lifted up my hands and I said, step foundation. And the man was so impressed. Please take notes. This thing I've said, stepped foundation, go and research it. Go and research it. It will make you a star. It will make you stand out. Imagine you're able to save your client. They were supposed to spend 700,000 in the foundation alone. But because you've come in as a super engineer who's got pillar number one, which is the scientific understanding, and pillar number two, the construction method, you suggest let's use a stepped foundation. You save them instead of them spending 700,000, they now spend 300,000. You know what? Even if they don't give you that money, that's the difference. They'll be able to recommend you to somebody and say, work with that engineer, work with that company. All right. Right. Physical tools. So there are tools that we lose, which is pillar number three. There are tools which are physical instruments and digital softwares. So this can be the most basic thing that every person that is interested in infrastructure, in building, is that you must have at least have a measuring tape. Go out if you don't have one, even if you're a student, you're what, please go out tomorrow, buy a measuring tape, a steel measuring tape, preferably. Why? Because steel isn't easily manipulated, out to the weather and things like that. Be practicing, even if you don't have a project, know what a 5 meters looks like. It will save you. These simple tools will save you. I remember there was a project we were doing. It was a very big house, big kitchen. I'm not there. The bricklayer sets out and they begin to build it. I walk to site. Just by looking, I could tell that it was wrong. Last year, something similar happened. We have got a project. This is a house we are doing. I'll just say rough between 5 to 7 million. A house that is between 5 to 7 million. Clients, good people. We had this guy who was masquerading as a foreman. So, he presented himself, gave us. That's the reason why this time I'm a bit more strict when trying to hire people. Got this guy, took him to site. Oh no, I've done multi-story buildings, I've done this. So I'm not on site. I'm actually tendering. The time he's on site, me, I'm trying to get more projects. They hit the house, they even begin to build. It's looking very nice on pictures. I walked to site. I just looked. 2 minutes of being on site, I knew they have messed up. They've casted concrete in the wrong position. The kitchen is supposed to be 7 meters, is now 4 meters. That is, you see what I'm saying? Now, imagine if I didn't have the basic knowledge of even just how to use measuring tape. It might look very simple, it might look very basic. Would have lost a project worth 6 million. I'm saying it's 5 to 7 million because there's still other things that the client has been adding on. So they've bought more land, they're adding this, they're adding that, they're adding that. Losing a project of that magnitude because I don't know to do improvements. So these simple tools, every site engineer must carry, at least in your bag. I know you are lady engineers here, you have got handbags. Put in that handbag, one of the key requirements, get at least a minimum 5 meters steel tape. Be carrying it everywhere you are going. Even if you have gone for dinner, one day you need to measure the table there. It's okay, carry it. Listen to me, carry it. Things like the spirit level, simple things, dampy levels and things like that. I'm seeing that time will be out very soon. I don't know. Is this a paid for Zoom? I thought the session was 1 hour, so I was taking my time. Okay, so that other tools like GPS, of course, now I've also been learning with Engineer Chabala here. He's been teaching me how to use Python. They're equipment, they're heavy equipment. All right. So all these, but of course, there are software tools. You must at least know. I use a lot of what is called auto design review. That's mainly my software. If you're working with me, most of the people work with me, you do the AutoCADs. It's not that I can't, but I've just decided to specialize more into design review because it helps me mark up my drawings, it helps me plan my drawings, and from what I've now learned, you can integrate it into softwares where you can manage a project from the software I'm currently using. All right. So there are all these softwares that are there. Please, I hope that people, if you are doing your research, some more people need to research BIM. We need this technology because now our adoption rate is at 5%. Globally, they're at 70%. So we need to pull our socks. All right. There are construction software. There's things like QS Pro, other things that are coming on board, and things like that. Um, Particular software that is also quite cool, a Microsoft project. I'm actually taking a course right now in Microsoft project. I know the basics. I did the basics when I was in school, but I realized there's much more I can do. I can do my end value analysis using Microsoft. So tools are quite important for you to begin to know and understand. All right. Okay. So basically,
Sorry,
those are some of the tools.
sorry. I wanted to say, I think immediately after it just cuts, since it's not a paid one, we can just rejoin again.
Okay, engineer. So for the next one, please get in touch. I'll pay for it. We
Oh,
can't have that happening.
oh, okay. Thank you very much. Huh?
So at least I'm sure you can have it paid for the month, and I'm sure things can. All right. So you're saying after. So please, everyone that is on the call, when it disconnects, we'll reconvene. So now let me give another example. So listen, you might not need to know everything about it too. Like a dumpy level, you might not be because there are surveyors. The complexity of the project and who you're working with, who you're working for, they might bring a surveyor. But in case they don't bring, at least you must be able to do the basics. Or even listen, I've got notes on how to use a dumpy level, for example. Even if you don't know everything, if you take a reading from this level and take a reading from that level, when it's supposed to be on the top of the slab, you know it's supposed to be the same reading. So at least you have that idea. Consider a task. These three pillars in practice. Consider a task while you are designing and constructing a reinforced concrete strip foundation on an African site. Pillar one tells you how to calculate the required foundation depth, width, because you know from the loads and Shanyuko, you can count based on the soil bearing capacity, you are able to do that. Pillar number two tells you that the local laterite soil is reliable when dry, but softens in the wet seasons, requiring a deeper foundation, right? Than the formula alone suggests. So your formula might show you to say, okay, yeah, you need to have this type of a foundation and things like that. But when you're on the ground and you understand construction, you'll be able to look at the saw and know to say, I can't use this. So I have to go deeper. Pillar number three will allow you to use your dumpy level to set out the level of the you. So you've got the knowledge, the understanding, you've got um, the construction technology, what's supposed to
Anyway,
happen,
usipuli wote nikuvuta.
and pillar number three, you are able to actually execute. All right. So of course there are other technologies that are coming on board. Like I said, our adoption rate in Zambia, in Africa generally, is that we're about 5 to 15%. Very uh, most of the softwares we're using. We've got 2 minutes. I don't know if I can still start a new thing on 2 minutes, or maybe I can clarify something quickly within a minute that maybe I have said that was not clear. I've noticed some people are saying I was not being very clear. I wish I could use. I don't think these are connected. Is there anything you'd like me to address before we go? Okay, I've seen people have put answers in there. I want to give you a simple assignment. I want you to do this assignment in your own time. Imagine you are working for Sky Pillars, and I want you to do a three-tier level work breakdown structure of a house construction, but I just want you to do a work breakdown structure up to slab level. Up to slab, and that's it. Just a work breakdown structure up to slab level. Bear in mind in the assignment I'm giving you, bear in mind that the kitchen for this, it's a 500 square meter house. All right, it's a 500 square meter house, and it has got island a kitchen that is an island with plumbing and electrical coming from the slab. So I want you to just in your own time, I'm not saying you do it now, create what is called a work breakdown structure. A work breakdown structure is useful because then you can use it for estimating your sequencing, what is your time scheduling. You can use it for also estimating your um, tomorrow, my office manager is not an engineer, but tomorrow, her and the intern, one of the interns that we work with, I want to take them through how to create a basic estimate of by using the work breakdown structure. Because I realized that sometimes when I give them, because like we're doing some work at the farm, for example, but they haven't been able to give me a clear estimate, and I'm too busy for me to start estimating piggery and things like. I will skip my chapter 2, which basically deals with uh, pre-site mobilization or site establishment. I think I can share it with Engineer Ngulube. Is one of the things, because we are trying to grow our business, is I'm now trying to set up what are called standard operating procedural manuals. So I set up one thing that is called our manual for site establishment. So basically, that's what I teach on in this. One of the key things that I would like to highlight to you is this thing called the method statement. You must be able to prepare a method statement. Again, it comes from you being able to know this is the sequence of work. This is what is required when we are excavating a trench. We don't say digging a trench, we excavate a trench. When we are excavating a trench, we we use picks, we use this, we use that. So your method statement describes the procedure, the sequence in which it's done, the tools required, and the workmen required. All right. Um, so here's what we've said, the Sky Plus practice. One of the things that I'm trying to do in my manual is trying to, like, literally, because I want to use this to train even people that will be working with us as we go. So we require that you must have a completed and approved site layout plan, because how you set up your site actually makes a big difference. But like I said, because we actually don't have so much time, I'll go to, so the three deals with setting out and lively things that I which also skip that for today. All right, so first principles. Let's deal with this. Um, First principles of construction. The importance of site visits in construction projects. I'm not Chipo. I've been trying to pick on Chipo because I don't know if she's on the call. I can't see her. First principles of construction. The importance of site visits. Now, again, you are the engineer, you are the architect, you are the quantity surveyor, you are the project manager, whatever your role is. One of the basic things that you need to be able to understand if you're going to be a good practitioner of construction is you need to be able to understand what I call site visits. Now, these site visits that I'm talking about them before you have set up the site. All right. If a client approaches me to say they want to build a two-story house, I demand, can I go and see the site? A lot of failures to execute projects in Africa actually starts because we don't do adequate site investigations. Now, even before there, in chapter 5, I deal with the more detailed geotechnical surveys that you need to do and the types of disturbed samples and disturbed samples that you guys learn. But there is a thing called a preliminary site visit. Before you take on any project, ask to do a preliminary site visit. So in Africa, like I said, foundation failures, because we didn't detect. I'll give an example. There's a project we are doing. It's funded by the World Bank. It's in Kabompo. This project has been very hard to complete. Why? Because first and foremost, the World Bank, the World Bank people, they are consultants. They concentrate more on the social aspects of the project. So even the requirement with the BOQ, there's a big requirement on HIV training and things like that. Very good things because construction has got a social impact. But imagine a construction site, it's a sloping slide. No one picked it that it was sloping. The BOQ is done like it's a flat site. So me as a contractor, I send an inexperienced engineer to site who doesn't know how to read the drawing, doesn't know how to read the BOQ. We'll start executing the job without realizing to say, no, what is in the BOQ and what is on the site are two different things. Why? Because they did a poor job. They didn't do a proper site visit. They never understood. So I want in this segment, I want to be able to tell you principles that make you stand out when you have gone to a site visit. What are you looking for? Whether you are a contractor, you are a consultant, you are a structural engineer, if you don't know these things, you can be designing very nice structures in your head that cannot work on the ground. Or you can bid for a job thinking you're going to make a lot of money. When you go on ground, you're making losses, you're crying. You can give a client bad advice when you don't understand this thing called a site visit. Why I was trying to call on Chipo because I did a site visit with her not too long ago. We went to see a particular site, and in practice, I was able to teach her the things that I'm about to teach you. So a site visit should be always be conducted detailed planning, design. But what do you look out for? All right. The objectives of a site visit to understand the physical characteristics of the site. You need to be able to understand the physical characteristics of your site. Second, you need to be able to know the construction constraints. There are some sites. It's a good site, but it's got some surface pipes passing underneath. I don't know if you saw that scenario in Lusaka where a family had built a house on a big pipe for Lusaka water and storage. And eventually, because the settlement, the weight of the house caused the pipes to burst and water flooded the house. So you need to be able to pick out. Of course, there are a lot of new areas that are being opened up, But again, when you go to a site, you're able to know, oh, do we need to do a septic tank? Again, I'm not a very big fan of septic tanks because I want sustainability. So septic tanks are not a good thing for me. All right. You need to also to evaluate environmental conditions. Things like natural ventilation. that designing your windows a particular way, putting your windows a particular way, can actually lessen your operating cost of that building. There's what we call life cycle costing. I'm going to talk a little bit about that. Now, very quickly, what are some of the things that you need to be looking at? So if I send you, I get Engineer Ngulube and say, listen, I've been invited for a tender in Lumwana. I've been invited for a tender in Congo. I want you to go and first spy on the land. This is what I'm expecting you to come back with. Number one, you need to be able to pick out simple, the terrain and the topography. The terrain and the topography will be able to, this is the physical shape. It will tell us whether we need to do a cut and fill, whether we need to do a retaining wall. There are some sites. There is a particular site I went to, and we didn't get the project, unfortunately, or is it fortunately? Because when they gave us the opportunity to go and do the site inspection, we did the site inspection. But then I noticed because there is a stream that is on one of the borders of the site, and it's a slopey site. I noticed that over time, land seems to be moving. There is a movement of land towards the stream. Meaning, if I'm going to build a sustainable or I'm going to build a long-lasting facility there, I need to be able to first and foremost do what? Build a retaining wall. I'm able to see that just by going to the site. I'm not able to design maybe in full detail the retaining wall, the detailing and the what at that point. But at least I'm able to think already to say the site is too sloping. Again, you look at the basic topography of the site. One of the big mistakes we make in this country is we allow the land, or imagine somebody is building their slab in the yard is at a lower level than the road side. You know what that means? I mean, you don't have to have a master's in hydrology to know that when there's too much rainfall, because of the way we pave our roads and things like that, meaning water will collect from the roadside and it will become, all of it will be coming into the yard. And not only into the yard, it will be coming into the house. A simple observation that an engineer, a contractor, a construction manager, an architect, and whatever your role is, could have picked out. Simple. You didn't even use, like, you don't even need to use a damping level at this level. Just be able to notice to say, from this side to that side, this is how it goes. All right. So that's one of the things that you have to look at. Number two, you look at what we call vegetation. You look at the vegetation. There are two reasons why you look at vegetations. First, is that in the same house in Lusaka, this project, it was sent to me. The client is in America, so they sent me the drawings, and I found my friend is actually the one who designed it. He's an architect. I look at the house, everything is it's a beautiful house and everything. I've not gone to site. We got to site. You know what we find? Trees. A lot of trees that needed to be cleared before we could set out. Now, imagine, like I said, you are my project manager. I've left that project to you. You undercut. You don't put uh, site clearance as part of the bill. We go to this, we find big trees that requires to even hire equipment. Something happened in Kabompo. It wasn't our fault. The consultant didn't know which site they wanted. The site that was clear, and eventually said, "Okay, use this site that is." Hey, guess what? Contract administration. I claimed for the money. Cutting a tree. I said, cutting this tree. One tree is 5,000. No, but they said one tree is 5,000. They had to pay us because we have to get equipment to come and push, and we cut these trees, and then it's just so you have to observe those things. But vegetation is also important for other reasons because there are some type of plants that only grow in waterlogged places. So why are you visiting a site in the dry season and it has got green vegetation? Elsewhere, all the other land is the grass is brown. You as a person who's wanting to build something, it should already click that there's something. Either the water levels are too high, the water table levels are too high. Like there should be something happening there. So vegetation tells you the story of the water that's there. All right. So, and also, again, because of sustainability, when you're cutting trees, you must be making other plans on how you're going to soil conditions. Of course, I mean, You have not been awarded the contract at this level, so you are not doing a very detailed site investigation. But at least you must be able to know, even you know, okay, there's black soil. If there's black soil, can we build on black soil? What do we do to build on black soil? It's possible to build, but it's gonna cost us more. We need to maybe put ground beams, those type of things. Maybe instead of having a foundation, can we do a pad foundation? So the soil conditions, an engineer, a site person, a construction practitioner must be able to look at the soil and be able to already begin to theorize and think what they can do. All right. I hope you're taking those notes. Drainage and water flow. Again, understanding how water moves around the site, very important. When you read E. Barry's construction of building, he highlights what is called French drains. Now, the problem we have in Zambia is that our main drainages don't go anywhere. So how do we now drain out our sites if they need to be drained? If we're building in a waterlogged place again, there are things, there are additives to, I want you to look up a material called Mr. Fixit. Mr. Fix-It, is it Dr. Fix-It? It's one of the additives you can add to your concrete to make it, or to your cement to make it more waterproof. Same site I was telling you about, a client, I told them about the material, they ignored me. They built something and water was coming through the foundation, literally coming through the concrete. I then go back to the site. I get Mr. Fix It myself. I mix it with the bricklayers. We seal it off the concrete. Water stops coming up. When I walked to the site the following day, the bricklayers were, we are very good. You know what? They were praising me like I'm a star. It's simple things. I understood water, how it moves around that site, and I understood that. So apart from drainage, there are additives to your concrete that you can be thinking of. This is a very critical thing, and that's why I was busy calling out Chipo, the neighboring developments. When you're visiting a site, always look at what's happening if it's an area that is already developing, look at what is happening in the area. So we went for a site visit with Chipo and some other people from the office. We are in this yard. So them were looking at the yard and everything. So eventually I asked them to say, what else have you noticed when you look at the neighboring plots? They didn't say anything. Then I pointed out, do you realize that the building next to us here has got big cracks? The building behind us has got big cracks. The nature of the crack is telling me that this is not normal cracking. This is not normal settlement. This cracking is telling me there's a lot of movement in the ground. Here, this soil that they have built on the original ground. Immediately I said, the owner of the property said, no, you are very right, actually. There was a huge canal that passed from here into the neighboring land. So we just started pouring land, gravel into it, and then eventually we built. So when they built, already, I was able to pick it up because I looked at the nature of the cracking. I inspected the property, I think 3 years ago for a white lady. Spent a lot of money. She's a white lady near Mlungishu University, big farm. She built this house, and the contractor, I think underpriced. I don't know what he did. He was very minimalistic when it comes to reinforcement. On the open, instead of doing a ring beam, he just did lintel. But even a lintel, there's a minimum measurement. All right. If I was doing sketches for you, I would show you the minimum measurements that there is to point out. They were not following the minimum measurement, and because of that, the thing was cracking. The client thought that it was the entire thing that was cracking, maybe because of settlement, and we needed to do underpinning. But when I looked at the nature of the cracking, I said, let's chisel here. We chiseled, and I told them there's no reinforcement. And true, we found that there was no reinforcement. Again, I was looking like a superstar. Why? Because I was able to pick out the problem just by looking at what is happening around. So, whenever you are developing a property, whenever you're doing any works, always strive. You are working on a road, you are working on a bridge project. The downstream, the same stream was able to sweep out a bridge on the other part. It's the same stream that is passing here. It should tell you a story to say, let's take certain precautions. So it is always important for you to have a lookout when you're going. These things will help you. Again, things like access to sites, very, very important. So what are some of the documentations? Now I'm being practical because I'm not telling you theories that I'm trying to get your theory and apply it now to real life. When you go to site, some of the documentations we expect from you, you have a nice smartphone. It's not just for taking those nice selfies. As an engineer, learn how to take site photography. Learn. which angles, which what you can sit down, even if I was not there, me as your boss, I'm not there, or your client is not there. The angles you've taken of the site should be able to tell a story. All right. You must be able to capture nice pictures. So that iPhone thing that you bought as an engineer is not for you to go to these nice eating places and go and take bathroom selfies. Make sure you take nice pictures of your sites, because then you can document them and you can put them in your reports and things like that. You must be able to make sketches. Hand-drawn sketches annotated with dimensions, slope directions, drainage flow directions, location of key features. So when you're on site, if it's a site that has got services, for example, you are able to say, oh, you have identified, look, the water utility line is here. This, I mean, imagine your boss has sent you to a site and you come back with a nicely done sketch which explains. He'll be impressed to say, oh, this guy knows how to take note of what is important. So written field notes, soil color, texture, vegetation types, density, preliminary measurements. Like I said, be able to, I wish I could bring my tape, I show you to say, I'm not just telling you, I don't know how many tapes they have stolen from me, my bricklayers, but I stood by every time I lose a tape. I can't live without a tape. Go to a site, you're able to make the basic measurement. Okay, the width is this, which direction is facing the road. All those things are very, very important. In modern construction practice, site information is increasingly integrated into digital project models using BIM. Field data captured on smartphones or tablets can directly be uploaded to a cloud-based project platform. So like I said, have a notepad, have somewhere where you are writing what you are seeing. All right. So you must be able to visit sites very well and come back with useful information. Again, like I said, don't go to site, just go and look nice and you are, we like, vibes, as a manager. Yes, please, I'm not against that. Build your personal brand by all means, but make sure you're also capturing important and essential information. Okay? So your direct observational skills are more critical. In Africa, not many clients do a geotechnical survey. You tell them we need to spend another 100 pin to do a geotechnical survey. They will look at you like, "Ah, but we don't need it. My neighbor didn't do it." So your observational skills are very critical. Please, I hope you have understood and have learned how to effectively conduct a site visit. So site visits are essential before planning any construction project. Understanding the terrain, the soil, the drainage, and the neighboring development helps us avoid design errors, costly variations. Observations made during site visits directly influence foundational design, construction methods, project costs. Proper documentation of site observation supports informed decision making throughout the project life cycle. As a project management profession, I emphasize what is called project life cycle. There is a construction life cycle, project life cycle. There's a building life cycle. So this simple thing that I'm teaching you now, this simple thing I'm teaching you now, trust me, is so critical to your project success or not. Now, um, let me deal briefly. Let me deal briefly with how buildings carry loads. Again, you have to have a basic understanding of loads. So there's tension, there's compression, and there's shear. I'm sure you've done these things. I remember at some point when I was doing structural mechanics, I was not paying attention to these things. Then I realized they're important later on. All right. So anyway, load categories, we've got what we call dead load, which is the weight, the self-weight of the structure. Live loads coming from occupants. They've got things like wind loads, seismic loads, snow loads, which are not, okay, like in South Africa or in parts of Lesotho, for example, where it's not, all those loads are quite important for you to understand. Why? Because, like I said, why do you need to understand the basics of the load? Because you need to be working. If you are working, you realize, okay, so for example, I'm working and I'm building a warehouse. I've built a warehouse before. You're building a warehouse, and I look at the design mix of the concrete. we're doing in situ concrete mixing, and it's 1 to 4 to 5. I look at the heavy equipment that's coming there, the live weight. I realize that this is an under design. All right. So there are some structural systems and things of that nature. I wanted to introduce a little bit on materials, so I'm just trying to skip. So there are things like concrete tests, cube tests. Again, I think I can put them. I'm supposed to have, I don't know how many sessions. I can't remember what the engineer said, but anyway. So site measurements, setting out. Again, I'll skip this for now. But I want to, maybe as I skip this, can I talk about what is called the 3-4-5 principle? I want somebody to explain to us. You can unmute and explain to us what, when you're setting out, what is the 3-4-5 principle? Very quickly before I point at you, I start pointing randomly. Do we know the 3-4-5 principle? Please, can I get a response? If we don't know, just say we don't know. The reason why I'm not tackling setting out, because I think I would have required to do
Hello?
some sketches. Maybe I'll try and do some sketches next time I come so that I'm able to show you. Do we know what the three,
Hello?
four, five principle?
Yeah, can you get me?
Yes, I can get you.
I just want to try. I think it is when you are trying to make a 90-degree, because 345 is more like a triangle which can give you a 90-degree if that's a corner or somewhere where you want to make a 90-degree when you're setting out. That's my suggestion or my thinking.
You're actually very correct. It's a very simple thing that is very foundational. When you are setting out or when you are measuring, if your bricklayer is working, you want to know whether he's being accurate. You measure a 3 on one side, on this side, and a 4 on this side. The what do we call it? The thing in the mid, what do we call it? Hypotenuse.
Yes, I butchered it.
Yeah, the hypotenuse is supposed to be 5. If it gives you 6, that means that angle, that corner is not okay. So you see, those are some of the ways you can shine as an engineer. You're a new engineer, you go on site. Yeah, they're asking you because you're supposed to be in charge of quality control. So I know this corner is not straight. You get your measuring tape, you do a 3, you do a 4, then you come and check in the middle. You see, it's giving 6. So can we break this wall? And you get the building square, you pass, it's confirming what you're saying. So those are simple things that I want you guys to be doing and to be excited about. Like I said, these are foundational principles, and they are very, very important for you to understand. All right. So please go and research a little bit more about setting out. Like I said, I can't cover everything in this session, and of course, there we talk a little bit in my manual. I talk a little bit about um, the dumpy level. We just bought a new dumpy level for our office. I'm actually excited to set it up. Let's go and use it on site. All right. But the water level, again, that's your assignment. Go and research a water level. Very simple. It just works. Water finds its level. That's the principle and you see, the thing about dumpy level, because you have to keep moving, doing the stuff and things like that, it's good. It's very accurate. But the water level is able to transfer. Once you set up the desired level, you are able to easily transfer it using a water level. When water finds, because basically the water level is just like a pipe. A pipe that is clear. If you want, you can even put a colorant into your water. so that you're able to see it clearly. When you've put a level, when the water level is here, and you want it to be, water stops moving when it reaches its level. So if it's dropping, it means that the level this side is not okay. Very simple principle. Very useful when we are setting out trusses on roofs. We are setting out, like, it's a very useful thing. I've done a bit of writing on that. I never learned that principle. Like I said, I never learned the water level in class. I learned it on site from some guys who had been working with some Chinese. All right. So we've got 10 minutes. So I'll end my lesson for today here. Um, yes, I'll end my lesson. I think in my next session, I'll be able to deal with, but it will be a paid session so that we can at least cover more ground. I will end here. I'll stop my sharing here. Thank you so very much. Again, I don't take this lightly. I believe that this platform has got an ability to change a lot of things in the continent and in our personal lives. So I'll now open it up. I'll give it back to the hosts to take.
Uh, Thank you very much, engineer, for the knowledge. If there are any questions, you can, I think, if there are any questions, you can just write them in the comment section. So I'd probably I can read them and direct them to our guest. Um, so if there are any questions, I'm repeating. If there are any questions, you can just write them in the comment section so that we can direct them to our guest. Uh, yeah. For this one asking, is it possible to access the recording to review during the week? Yeah. All our sessions were recorded, so immediately we are able to retrieve the recordings. We'll send them actually on all our social media platforms. Yeah. Reading this other message. Can we have the document shared for our benefit as upcoming engineers? Yeah, definitely. We'll share everything that was actually even the notes. Even though you're not done engineer, it's at I can see here it's showing 31 out of 93 pages. Okay, Mr. Engineer, I think we have a question. Are you on the line, Engineer Chulumanda?
Yes, yes, I'm here.
Okay, there's a question. This question is I'm a final year master's student of construction technology and management at I don't know what at IIT Bombay, India. I would love to get in touch with you after the session, and I'm certain the other guys in the meeting would appreciate if you send us your contact. Oh, he wants actually your contact details. I don't know if it's all right.
All right. No, I am open to networking and sharing with people, collaborating. Who knows, some of you will be able to be the ones who give me my big project. Um, yes, so that's something that I will do. Maybe for a start, you can reach out to me on my LinkedIn. I'm just typing out my name on LinkedIn. Oh, but no, I mean you already have it here. Yeah, and for my number, I mean it's already in the public domain. You can also get my number. That's fine. So you can reach out to me on on WhatsApp. Yes, I of course I must tell you that sometimes I might not respond to you because I'm doing a number of things. I am an engineer, I am a farmer, I'm a student, I'm doing some research. So that's quite a lot on my hands. So if I don't respond to you fast, please don't be offended. I have people get offended. It's not intentional. So I've sent my WhatsApp number as well. You could reach out. It's very fine.
I've seen something Something very important in the comment section from Natasha Kashempa. So she's asking, in the spirit of bridging the gap, are you willing to take up any more interns?
Okay, so internship is something that we are actively doing. Um, Now, my dilemma, my challenge is we are also trying to scale the business. So if I take up more interns or people that require me to teach them, people that have worked with me as interns will tell you that we have lecture sessions. I will sit down and start taking them through. Some of the things that we are talking about here are things that I've taken them through. I take them to sites and so very demanding. So definitely, we are going to continue with our internship program, but it's not yet at a level that maybe that it can take up a lot more people as it is. We can take in people as we are going and creating more space. What I need currently are people that are also able to come in and already contribute, right?
Okay.
That's And then there was another question whether I've worked in the mining sector. I'm currently doing some projects in the mine. With some mine, I'm doing some quality assurance for some dam constructions with my team. I think we were there not too long ago. We were sharing, yeah. So the principles of construction infrastructure are the same. If I teach you how to do construction, trust me, you can apply this anywhere. You can apply anywhere. Whether it's in mining, in agriculture, it's universal. Maybe very quickly, because I'm not seeing other questions, I can show you some of the books. I'm a person that collects books, so I have a lot of books with me that, of course, because also of the masters, I have. So all these are some of the books. Some of my friends wants to steal my book. I want to mention it. This is building organization procedures. This book has got templates. It's got basic anything you need to know. You need to know from a contractor side, from a designer side, template of how to do works methodology, how to do a schedule of works, how to do a letter for this. Saved me a lot in my first job. Construction contracts, law and management. I'm using this even for my master's. Great book as well. I mean, that's another aspect which we can talk about later on, contract administration. This also deals with contract administration, procurement. Again, some of you are unemployed at the moment. Learn how to do EGP. You can be doing EGP for a lot of these contractors who are related to politicians don't know how to produce or how to tender. You can learn that. I've met grade 12 people who are doing that and they're making a lot of money. I've made money. There were times because I had stopped my business for some time. The last 5 years, I was not really active in business. I was doing a lot of other things. I was being more self-employed. But I would tender for people. I tender for someone, they give me a 15,000. I'm okay. I'm good for some time. You know what I mean? Imagine I'm doing that every week. I'm making good money. I get a 4,000. So learn procurement, tendering, a big part of construction
Just a
management.
quick one, Engineer
Uh,
Chulumanda, before we cut. I think
yes.
it would be very much important one time we should have a session about how to position yourself as a young engineer. Because
Okay.
yeah,
That's
yeah,
not a problem.
yeah, I think that one would actually be very important. In fact, how are we supposed to position ourselves as young engineers? Because mostly we're waiting for people to actually find us. How about
No,
we?
no. Let me quickly say something that I want it to be practical. My first job, I'll tell you something. My first job, I don't want you to do it like me. I was a volunteer.
Okay.
I engineer Ngandu, Abel Ngandu, they were doing that stadium that he talks about for Rwanda. So they needed some people to help just do some calculations and everything and they take off. So we're a number of us engineers, quantity surveyors, we're all in one place like this. And I worked. I have less than a minute. I hope to finish what I'm about to say. When I worked there, I didn't have a job. I went to the to the guy and I told him I want to volunteer. I volunteered. Then we went for a site meeting. When we went for that site meeting, I got a template from this book on how to do site minutes. I did site minutes Following week, he employed me. He said, none of the people I pay very big amounts of money have been able to do proper site minutes the way you have done. These ones, I can use them in court, I can use them anywhere. Some of you, you're not employed. They are contracted in the house next door. Go and volunteer to supervise. I know I'll supervise for you for free. Start somewhere. You know what I mean? Don't be a person that's just waiting for the KCM, the what, the big guys to call you. All right? Start with what you have, start where you are. Be humble enough to